everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to begin Section 1 of Chapter 2, Slope-Intercept Form. So this section is all about being able to identify slope, y-intercepts, and being able to graph a line on the coordinate grid. So the slope-intercept form of a linear equation is written in the form y equals mx plus b. This equation is super important because many of the linear equations we work with will be written in this form, y equals mx plus b. Now the reason it's important to know this is because this form is the easiest form to graph on a coordinate grid. In the equation, the m and the b stand for two important parts of a graph. The m, which will always be the number right in front of x. M is the slope of the line, and slope is always your rise over your run. And we'll talk about that more when we talk about graphing. But the key thing to know is that anything in front of x is your slope of the line. The other important piece is to know what the b is. And b represents your y-intercept on a graph. Your y-intercept is always written as a point, and that point would be always 0, comma, whatever number the y-intercept is. So the two key pieces from slope-intercept form come straight from the name. Slope and then y-intercept. So we're going to talk about using this form, identifying the slope and y-intercept, and being able to graph a line from this form in this section. So our first example says identify the slope and y-intercept of y equals 4/5 x plus 2. So what we want to keep in mind is right now we're talking about slope-intercept form. So all our equations are in this form, y equals mx plus b. So when we want to identify the slope, slope is always represented by the letter m. So we're going to say that m equals, and then we're going to look in the equation from slope-intercept form and write down the number that's right in front of x. In this case, that number is a fraction. So we're going to say the slope of this line m is 4/5. The y-intercept is always what is being after the x. So if we take a look, we have the plus 2, which is in the b spot. It's what's being added to the mx. So we're going to say that the y-intercept, which I abbreviate intercept int, the y-intercept, writing it as a point, is 0, and then that number 2. So the y-intercept is 0, 2. Our next example, identify the slope and y-intercept of y equals -3/4 x minus 5. So again, we're working with slope-intercept form. So our equations are in the form y equals mx plus b. So when we identify the slope is represented by m. And that's what's immediately in front of x. It's the coefficient of x. So in this case, we're going to say m, which means our slope, is equal to, and right in front of x, the coefficient is -3/4. So our slope is -3/4 for this equation. For the y-intercept, we're going to take a look at what's being added to the mx or what's being subtracted from it. So in this case, we have a -5. So even though this says plus b, this would be like plus a negative. So plus b is fine. This tells us that our y-intercept, we just got to make sure to keep the sign with it. So the y-intercept would be 0 and then -5. So it's sitting at the point 0, -5. Our next example says identify the slope and y-intercept of y equals 2x. So again, everything in this section is slope-intercept form. So we're looking at y equals mx plus b. So when we identify the slope, we're looking to see the coefficient of x. What's immediately in front of the x? In this case, our slope is 2. So your slope can also be a whole number. So the slope is 2. And then I also need to identify the y-intercept. So if I look, what's being added or subtracted? Well, there's nothing there. So if there's nothing there, I've got to think about what number means I have nothing. Well, the number that means I have nothing is 0. So this is almost as if there's a 0 being added to the 2x, because I don't need to write down if I'm adding or subtracting 0, because that doesn't change anything. So when nothing is being added or subtracted, your y-intercept is always at the point 0, 0. So when nothing's there, think about what number means you have nothing, and that is 0. Our next example says identify the slope and y-intercept of y equals 10. So again, we're still working in the form y equals mx plus b, your slope-intercept form. And we want to identify the slope and the y-intercept. So again, the slope's represented by the variable m, and m is what's immediately in front of x. So if I look at this problem, there is no x in the problem. So the only number that's going to mean that I have no x, what number means you have nothing? Well, that number is 0. So in this case, my slope is 0 because there is no x in the equation. So m equals 0. The y-intercept, however, is in this problem because you have the single number 10 with no variable with it. So our y-intercept is actually that number that y equals. So our y-intercept would be at the point 0, 10. So now we're going to take a look at graphing a line from equations written in slope-intercept form. So our first example is to graph y equals 4/5 x plus 2. So when you graph from slope-intercept form, you want to identify your slope of the line, and you want to identify your y-intercept of the line. So in this case, our slope of the line, the number in front of x is 4/5. And our y-intercept, what's being added or subtracted, is 0, 2. So what we're going to do when you graph a line, you always start at your y-intercept when it's in slope-intercept form. So we're going to go to the y-axis, which is the vertical axis, and we're going to plot a point at 2 on this axis. So positive 2, and we're going to put a point right there. Once you have plotted your y-intercept, you then use the slope to finish graphing the line. So in one of the first slides, I said that slope was rise over run, and that we would come back to that when we got to the graphs. So when we say slope is rise over run, we have to count 4 units where we would rise from our y-intercept and 5 units where we would run from our y-intercept. So what we're going to do, we're going to start at our y-intercept 0, 2, and we're going to count this rise over run. So we're going to rise 4 units. We're going to go up 4 places, 3, 4, and then from there we're going to run 5 units. Now, since it's positive, we're going to go to the right. 1, 2, 3, 4, 5. And where my cursor has landed is where I would put my next point. Now, I also like to have a point that's to the left of my y-intercept. So I like to graph 3 points and connect them to make a line. So we just counted, so we had a point to the right. To get a point to the left, I need to count the same numbers but go the opposite direction. So we just went up and right. So this time I'm going to go down and left. So we went up 4 units. This time I'm going to go down 4 units. It's still rising, it's just going down. And then I'm going to run left because last time I ran right. And I've got to run 5 units because the run is 5. And where my cursor just landed, that's where I would plot my other point for my graph. I went down 4 and left 5 this time. Now that I have 3 points, I can easily see that they're making a line. When I plot my points, if I don't see a line between them, then I know I probably put a point in the wrong spot. So we need to connect these to make our straight line. So what we're going to do is, as best as we can, draw a straight line between these 3 points. So if I connect them, I'm going to make it the size of the graph, and I'm also going to put arrows on the end because lines go on forever. They don't just stop where the graph stops. So we put arrows to represent that fact that they continue. And that's how you graph a line. So let's do a couple more examples. Our second example, we want to graph y equals -3/4 x minus 5. So again, when we graph from slope-intercept form, we want to identify our slope, which in this case, what's in front of x, which is -3/4. I usually rewrite the negative, so it's with the numerator, because it's not with both numbers, it's just with one of the numbers. And then the y-intercept is also needing to be identified. The y-intercept in this case would be at -5. So we've got the point 0, -5. So when we graph, again, you start at the y-intercept. So on the vertical axis, which is called the y-axis, we're going to plot a point at -5. So right there on that vertical line. And then we need to count our slope. So our slope, again, is your rise over your run. So I need to rise -3 and run +4. So what I'm going to do from my y-intercept that I just plotted, if I rise -3, well, that means I need to go down 3. So I'm going to count 3 down. And then I have to run +4. So I'm going to go right 4 units. And right there where my cursor has landed, that's where I'm going to put my next point. I then like to count the opposite direction, just so I have 3 points so I can clearly see my line. So what we need is, since we just went down and right, we need to go the opposite directions and go up and left. So again, starting from the y-intercept, this time we're going to go up 3, because last time we went down. And then we're going to go left 4, because last time we went right. So we got to make sure to change both directions. So right there where my cursor has landed, I'm going to plot my next point. Once I've plotted all my points, again, I should notice that they're lining up to form a line. And then I'm going to connect them to make my line, connecting as straight of a line as possible that I can. So, if I connect these into a line, doing the best that you can to hit all of them. It's best when you have a ruler. And then putting arrows on the end of your line, because your line will go on forever. It doesn't stop just because the graph stops. Our third example, we want to graph y equals 2x. So again, we need to start by identifying our slope of the line, which in this case is 2 because that is the coefficient in front of x, and by identifying our y-intercept of the line, which in this case there's nothing being added or subtracted, so we can assume that there's a 0 there because 0 means nothing. So our y-intercept would be at the point 0, 0. So to start, again, you start at your y-intercept. So in this case, we're going to start at the origin and plot our point. And then from the origin, we count our slope. So in this case, our slope is 2, but we know our slope is representative of rise over run. So I need to write my slope so it's a fraction. So think about whole numbers. We make them a fraction by putting them over 1. So what I'm going to do is from my origin, from my y-intercept, I'm going to count rise 2, and then I'm going to run 1. And that next place where I land, that's where I'm going to put my point. I can count my slope again from that point if I wish, or I can count the opposite direction from the y-intercept. I like to go both directions, so I'm going to count my slope again from the y-intercept. And since the first time I went up and right, this time I'm going to go down 2, and then I'm going to go left 1. And I'm going to plot a point there. Now your 3 points should line up so they look like a line, and what we're going to do, we're going to connect them into a nice big line. So when I connect these, I don't just want to do it the parts where I have the point, I want it to extend. So as best as we can, keeping it as straight as we can, because lines are straight when we graph them, we're going to draw a line with 2 arrows on the end. Our fourth and final example is to graph y equals 10. So for this problem, we see that there is no x value, which tells us that our slope of the line is 0 because there's nothing there. And then our y-intercept of the graph is at the point 0, 10. So just like previous problems, we are going to begin by plotting the y-intercept 0, 10. So I'm going to go to the y-axis or the vertical axis and plot a point at 10. And then from there I need to count my slope. So my slope is 0, but I need my slope to be rise over run. So I need to have this written as a fraction in order for me to graph it. So to put any whole number as a fraction, we just put it over 1. So we're going to count the slope from the point that we just plotted. So we're going to start at the point 0, 10, and we are going to do our rise over run. So we're going to rise 0, so I'm not going to move up or down any, and then I'm going to run 1. So right next to this point, I'm going to put my next point on this graph. Then I can also count the slope going the opposite direction. So if I start again from my y-intercept, we're still not going to rise any, so we're not moving up or down, but then I can also run 1 to the left and put a point there. So we can see when I go to connect these 3 points I have put on the graph, they're going to make a horizontal line. So what I want to do is connect them, but I'm going to connect them so I'm basically going the whole length of my graph because I don't want to do anything itty bitty. So connecting them going this whole length, we'll see that we have a horizontal line at 10. This concludes our lesson on being able to identify slopes, y-intercepts, and graphing a line from slope-intercept form. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.